Hi, in this video I will talk about the most common data structure used in programming, array list. Let's start with an example. You play Pac-Man and you want to keep track of the score you get. Naturally, you will start by setting the score into a variable each time you finish a game. So, you play one time and get the score, then you play again and save the score again, and so on, until you have so many values that you decide to store it in a more efficient way. The most common way of storing elements that belong to the same group is an array list. In this series, you will notice that the implementation of the data structures is heavily influenced by the way they are done in Java. Check the video description for the implementation in different programming languages. Let's define the operations we want our array list to be able to do. For that, we will create a new interface and declare the necessary methods. First of all, we want to be able to add items to our list. So we will create a new method add that will take two arguments: the index where we want to store the element and the element itself. Next, in order to retrieve the value at a specific index in the array list, we will create a get method. Then, we need a set method that will update a value at a given index. Remove will be used to delete an item by index given as an argument. Then we want some additional methods, like size to retrieve the current number of items in the array, isEmpty to check whether the array is empty or not, and iterator to create a new iterator object from the current array. Now let's jump into the implementation of the methods defined in the interface. The array list class will have two properties: size with the default value of 0 and the internal list used to save the data that will have a size given as an argument and will be initialized with empty values. As mentioned before, the add method takes two arguments: index, the position where to store the item, and element, the value to store. The very first thing we do is call the checkIndex method with arguments index and size plus 1 as the max index. This will erase an exception if the index is not between 0 and max index. Take this example. We want to add an item at the index 0. So we call the checkIndex with arguments 0 and size plus 1, which equals 1 since the size is 0. This method will pass successfully. Now, what happens if we want to add an item at index 2? Well, it will fail, since we have to check the index with arguments 2 and 0 plus 1, and the comparison between them will trigger the exception. Back to the add method, after checking the index, we want to compare the size property and the length of the data array. If these two values are equal, we will call the resize method. The resize method will create a new variable and will double the current size. Then it will create a temporary list of new size with empty values and will copy the values from the data list to the temporary list. And finally, the temporary list will become the new data list. Let's roll over a little bit and set the size to 0 and data to empty list. Now, if the index and the size of the data list are equal, we just set the item at the index position to be the element argument and decrease the size of the array list by 1. But if we add a new element in the middle of the data list, first we need to shift by 1 to the right all the items that start from the index to add until the end of the list. The get method that will take an index argument will call the checkIndex method with the same index and the max index equal to the size property. If no exception is raised, it will simply retrieve the item by index from the data property. The set method, used to update an element's value by index, will check for index availability, and if no exception is raised, the value at the given index will be stored into a temporary variable. The value of the data list at the specified index will be updated and the temporary value will be returned. The remove method that takes an index argument will call once again the checkIndex method, and if the index is good, the value from the index will be stored into a temp variable. Then we need to shift all the values that follow the given index by 1 to the left, opposite to what we did in the add method. Then we reset the value at the index of size -1, decrease the size by 1, and return the value that we deleted. The iterator method will create a new iterator object of the arrayIterator class. We will take a look at this class later. The size method will simply return the private size property of the class. And the isEmpty method will tell us whether the size property is equal or not to 0. Finally, there will be a toString method that will return the elements of the data property concatenated into a string and separated by a comma. The iterator class we mentioned before will implement the iterator interface and will have two methods, hasNext and next. The class will have a property that will keep track of the current iterator position and a property that will store the array list that it belongs to. The hasNext method will return the result of the comparison between the position property and the size of the array list property. The next method will compare those two values again, and if they are equal, it will raise an exception telling us that the next element does not exist. Otherwise, it will call the get method on the array and retrieve the element of the current iterator position into a temp variable. After that, the current position will be increased by 1 and the temp will be returned. In the end, let's test our classes by creating a new array list and manipulating it by using the created methods. Let's create a new array list of size 10 and add 10 new elements to it that will have the values of E1, E2, E3 and so on. Then let's add a new element at the position 2 that will have a value of new3 and output the result to see if the values are present in the array. You can see the output on the right. Now let's remove the element at index 2 and then the element at index 4 and output the result again. Notice what elements have disappeared from the array. Let's update the element at index 5 and set its value to new5. Then access it using the get method and output it. Last thing to test is the array iterator. Let's output all the items in the array as long as they exist in it. That's it for today. See you in the next video.